Multivariate networks are those that have both the structure of the graph as well as attributes associated to the nodes and edges. In this work, we conduct a crowdsourced user study to compare the two most common forms of visualizing multivariate networks, the node link diagram and the adjacency matrix. Let's take a look at how we encode attributes on each one, starting with the node link diagram. For tasks where we only need to show two attributes, we use size for the quantitative attribute and color for the categorical one. For more attributes, we use nested bar charts such as this one. The bars represent quantitative attributes, and small glyphs are used for categorical ones. Here's what a small network looks like with the nested bars encoding. We also consider edge attributes, where we use color to show the type of an edge and width to show a quantitative attribute, such as how often that interaction has happened. Let's move on to the adjacency matrix, which represents each node as both a row and column in a matrix. An edge is a filled-in cell at the intersection of the source and target node. We use opacity to show quantitative edge attributes such as count, and color indicates the type of the edge. Quantitative node attributes are represented as bars in an adjacent table. We use colored binary squares for categorical node attributes. Aside from the visual encodings, each visualization affords a certain set of interactions, such as dragging nodes or highlighting neighbors. Let's walk through the training guide our participants went through to see what each technique supports. We start by showing users the task instructions and the ability to search for a node. This highlights the node in the graph. Users can toggle the highlight on and off by clicking on that node again. Highlighting a node also highlights all of its neighbors. Users can also drag nodes around the screen. Hovering over a node shows a tooltip with exact values for the encoded attributes. The legend shows what attribute each bar and glyph represents. You can clear all highlighted nodes and click on a node label to select it as an answer. The training guide for the adjacency matrix was particularly important since the technique is often not as familiar to users as the node link diagram. Starting with the same search demonstration, we highlight how each node is represented as both a row and a column. A node can be unselected by clicking on the intersection of its row and column. To highlight neighbors, users can simply click on the node column label. They can further group all neighbors by clicking on the sort icon under the column label. We then move on to the attributes in the table, including the ability to sort them by clicking on the column headers. We can also sort the network by clusters, which reveals the structure in the matrix. Users can hover on an edge and click to select it. Selecting a node as an answer populates the answer panel on the left. We apply our study tasks to a Twitter network, which contains tweets during Euroviz 2019. We subsample the original network to create a large variant with 75 nodes and a smaller network of 25. To run this study, we use a crowdsourcing platform called Prolific, on which we recruited 300 participants, 150 for each condition. The study had 4 sections and took participants, on average, 40 minutes to complete. The training component had both a passive and an active section. In passive training, a video introduced users to the network and to the visualization approach they had been assigned. In this example, the video is teaching the user what an adjacency matrix is. After the video, users engage in active training with a hands-on guided tour to learn how to interact with the visualization. Before starting the study, users must answer 2 trial questions correctly. The study itself had 16 tasks, the first 15 of which were assigned in random order. The last task, shown here, was an open-ended exploration task, the results of which we used to better understand the types of insights that each visualization naturally supports. Insights included comments about the overall structure of the network, as well as people-specific insights. We also collected and analyzed rich provenance data for each participant, including when they searched for nodes, browsed away from the study window, or what nodes they dragged and which attributes they sorted on. Our results contribute the first set of empirical evidence on how these two techniques best support tasks that rely on both topology and attributes. Findings include superior performance of the adjacency matrix when distractors or non-task essential attributes were included, as well as confirmation of previous work on the advantage of the node link diagram for path-based tasks. We leveraged these results to propose a set of design guidelines for interactive systems supporting multivariate network exploration. For example, for networks with multiple attributes that need to be analyzed simultaneously, we recommend a design similar to our adjacency matrix. For sparse networks with few attributes, we recommend a node link diagram with color and size encodings. You can check out our study at this URL. Thanks for watching our video.